Hi, everybody. Professor Ken here. I just want to warn you that this video, which is an introduction to the April 20th week, may be a little bit lengthy because there's a few things I want to teach you here. First of all, though, I want to say that I've been reflecting about how much you guys have been working and how much you've grown over the semester, and it's very impressive. I mean, I looked to where you were at the beginning versus where you are now, and I've seen tremendous growth in most of you. So keep up the good work. I've also been reflecting. You've probably not taken a college class that has this many that has had this many assignments, and they've been kind of little assignments, but there's been many, and most of you have done them all on time and done them all pretty well. So I want to congratulate you on that. Okay, so let me visit Blackboard with you first. So let me share my screen. And if we go to this week's Blackboard, which is April 20th, there's a video that was made. We all contributed to the PowerPoint in the PET project, and I made a video, and I would like you to watch it. Then there's a discussion board, and it's pretty easy. What you have to do is click on this, and it says, what did you think of the PET project? Include thoughts of the survey, the Venn diagram, and the video. Just hit reply. Your feedback is important to me. Okay. Now there's a quick little warm up. Slides. This you don't have to worry about. I hit it anyway. And then a whole bunch of other little attachments that are going to help you with the week. So there's two assignments. One is about fun math facts, and it's pretty self-explanatory. The other is a geometry performance assessment, and that's what I'm going to spend time on now. So I'm going to stop the share. No, actually, I'm going to go to the Jamboard. All right. Now, the first thing I want to show you is the difference between 1 dimension, 2 dimension, and 3 dimension. And think about it in terms of an inch. So the length, that's about the length of an inch. All right, if I take an inch and make a square out of it, that's an inch squared or a square inch. Okay, and if I take an inch and I make a cube out of it, cubes are fun to make. Okay, that's an inch cubed or a cubic inch. Now, what would we measure? You know, I'm pointing at it, and I know you can't see that. This we would measure lengths with. So length is 1-dimensional. What would we measure this? We would measure area, for instance, the area of a rectangle. All right, so a rectangle is 2-dimensional. And what would we measure? Use these to measure? Volume. So in other words, how many of these little squares would it take to fill up the rectangle? That's the area of the rectangle. If I made this figure right here, this is a rectangular prism. Okay, how many of these little cubes would it take to fill up the rectangular prism? A rectangular, since it takes cubes, the rectangular prism is 3-dimensional. So, and then we would say, you know, what's the length of this segment? So using my mouse, the only thing we could use to measure this is this little unit right here. So it's 1-dimensional. What could we use to measure the inside here? This square. So it's 2-dimensional. What can we use to fill this up? The little cube. So it's 3-dimensional. So that's how we know 1, 2, and 3 dimensions. All right. Next, I'm going to talk about difference between area and perimeter. Whoops. Oh, crap. Hang on. I forgot to put it in pen mode. All right. So if I make this shape right here. All right. If I tell you that this is 12 feet and this is 4 feet and this is 4 feet, I could ask you to find the area and perimeter of this shape. I would have to tell you that this is 8 feet right here. Okay, now I can ask you to find the area and the perimeter. Let's find the perimeter first. We'd start, think about perimeter as if an ant has to walk all the way around, how far would the ant walk? So, going back to my mouse, from here to here is 12 feet. Now there's no number here, but we could see that this distance is 4 feet and this distance is 4 feet. So this whole distance must be 8 feet. Let's pen that in. So the little ant's going to be walking 12 feet. then 8 feet. Now look at this. This is missing 2, but we know from here to here is 8 feet, and from here to here is 12 feet, so the missing distance must be 4 feet. Let's pen that in. All right, so let's go back to the beginning. 12 plus 8 plus 4 plus 4 plus 8 plus 4. Well, 12 plus 8 is 20, plus 4 is 24, plus 4 is 28, plus 8 is 36, plus 4 is 40. So the perimeter is equal to 40. 40 what? Well, it's one dimensional, so feet. Okay, now we can find the area. And the first thing I'm going to do is make a little auxiliary segment here. And we're making it into two rectangles. So this area is length times width. 4 feet times 4 feet is 16 feet squared. Remember, to fill this up, we would need squares, so it's square feet. And this rectangle is 12 feet by 4 feet. So, woo! I hate that thing. So 12 times 4 is 48. So it'd be 48 feet squared. And then we would just add up the two areas. 48 plus 16 is 64. So the area would be equal to 64 feet squared, or you could say square feet. Either one is acceptable. Okay, so I hope that teaches you about area and perimeter. Now I'm going to teach you about surface area and volume. Okay, I'm going to make a rectangular solid. All right, and if I tell you that this is 10 feet or 10 inches, we use feet already, and this is 6 inches, and this is 7 inches. Well, to find volume, how many of those little cubes would it take to fill this up? Well, it would be length times width times height. 10 times, well, let's do 7 times 6 is 42. 42 times 10 is 420. So the volume would be 420 inches cubed or cubic inches. Now, surface area means, think about painting. What's the area of each side? And that's, we would have to paint that. So the way we find surface area is first to count all the sides. And this shape has 6 sides: top, a bottom, front, back, left, and a right. So we'll number them 1, 2, 3, 4, 5, 6. Well, why did I do that? I started counting by twos. My goodness gracious. Let me erase those. Sorry about that. Okay, so 4, 5, 6. The next thing we do is we want to name each side. So I'm going to call them front, back, top, bottom, left, and right. Now we find the area of each side. So the area of the front is 10 times 7, or 70. And the area of the back is also 70. The area of the top would be 10 times 6, or 60. And the area of the bottom would be the same. And the area of the right side would be 6 times 7 is 42. And the area of the right side would be the same. Now we have to add them up. So there's 4 ones, and then we have 7 plus 7 is 14, plus 6 is 20, plus 6 is 26, plus 4 is 30, plus another 4 is 34. So the surface area is equal to 344. Now we're painting, so we're using squares, not cubes. So it would be inches squared, or square inches. So that's how we find volume and surface area of a rectangular prism. And hopefully by watching that, you were able to understand the concept of volume and surface area. So volume, we're filling it up with cubes. Surface area, we're painting each face. All right, let's take a look at a new shape. I want to show you a cone. Cones are fun. Okay, so I'm going to tell you that the radius of the cone is 4 centimeters. And the height of the cone is 10 centimeters. Now, to find volume of any solid, think about it as the area of the base times the height. That generally works. Unless it comes to a point, then you do the area of the base times the height divided by 3. So in this case, the base is a circle. And the radius is 4. So we would do the area of the base, the area of a circle is pi r squared. So it would be 16 times 3.14. So I would have to go to my little calculator and do 16 times 3.14, and 3.14 is an approximation of pi, 50.24. So the area of the base is 50.24, and the height is 10, so it'd be times 10. Well, that's easy. We just do the decimal point shuffle and move the decimal point over one place. So it's 502.4, and this is volume, so it would be centimeters cubed. Now we're going to find the surface area. So we have to count up how many faces there are. Well, there's the top, there's the bottom, and there's the side. So there's only 3 faces. 1, 2, 3. Top, bottom, and side. Now, we already know the area of the top is 50.24. So the area of the bottom is also 50.24. Now, the area of the side, here's what I want you to visualize. I'm going to take a scissors and cut it along this side and unroll it. Then we have a rectangle. And the width of the rectangle is actually the height of the cylinder. So that would be 10 centimeters. And the length would be the circumference of the circle, which is 2 times pi times r, would be 8 times pi. Let's do it on our calculator. 8 times pi, 25.12. So the area of this whole side would be 251.2. 251.2. Now, if I add these 3 up, I get 8 hundredths, 6 tenths, 1 unit, 15 tenths. I'll put a 5 and regroup a 1, and then 10, 11, 12, 13 hundredths. So it'd be 1,351 centimeters, 1,351 and 68 hundredths centimeters squared is how we would say it. Okay, so all the slides show you how to find area, perimeter, and surface area of the different kinds of solids. But if we think of volume of a solid as the area of the base times the height, if the top and bottom are flat, or the area of the base times the height divided by 3, if the top comes to a point. I guess I should show that. So here we have a rectangular prism. You can do it like this. Okay, so you can see the depth. So here's length times width times height. So the area of this is equal to length times width times height. Now, what happens if it comes to a point? Well, then it's a pyramid. Okay, so we would have length times width, and then the height would sort of fall in the middle. All right, so basically, if you can kind of visualize this, how many of these can we fit into here? Well, if we go like this, we can see that there would be 3 of them. So the area of the pyramid is equal to length times width times height divided by 3, or 1/3 of that. All right, the same works with a cone, with a cylinder and a cone. All right, so here's the cylinder. And I told you before that the cylinder is equal to the area of the base, which is pi r squared times the height. Well, what happens if the top comes to a point? We have a cone, and we could see that there's 3 cones that make up a cylinder. So it would be the volume would be the area of the base, which is pi r squared, times the height. But then since it comes to a point and there's 3 of them, we divide it by 3. All right. And then finally, we would have a sphere. A sphere is like a ball. Okay. The volume of a sphere is 4/3 pi r cubed, because volume is 3-dimensional, spheres. And the surface area, if we had to paint the outside to get an area, we could just get rid of the 3's and take one away from the, so the surface area is equal to 4 pi r squared. Okay, so basically here's the relationship. We take this 3 up here, throw it out in front, multiply the 3's, cancel out, and subtract 1 from this 3, and we get 2. But those are the 2 formulas. Okay, so now you know everything you need to know to be successful in today's assignments. And I think you're like these assignments. They're kind of fun. They're kind of not really challenging. Well, they're a little bit challenging, but you're going to learn a lot and really think about the pedagogy behind it and how it could be engaging to kids, as opposed to the traditional ways in which you guys were taught about shapes and areas and volumes. All right, this is Professor Ken signing off.